Welcome back, everyone. We're diving into a paper you sent us. It's LM2, large memory models. You all are obviously interested in seeing how AI is getting better at handling information. It seems like even the best AI out there sometimes
Yeah.
struggles to remember information from long texts. It's like trying to remember a specific sentence from a book you read a while ago.
This new model LM2 aims to change that. It's trying to improve AI's memory, especially when it needs to reason through lots and lots of text.
So the researchers, they added a memory module
Right.
to that standard transformer architecture, kind of like giving the AI a dedicated workspace to manage information.
It's like giving it a place to organize its thoughts, yeah.
So how does that work?
Well, LM2's memory module uses a three-step process: input, forget, and output. You can think about it like organizing your notes, right? You add new information, you get rid of old or irrelevant stuff, and then you use what you have left to answer questions or finish tasks.
This forget step, that's interesting. How does the AI decide what's irrelevant?
The model uses specific criteria and algorithms to decide how important and relevant the information is. Outdated data or less important stuff is removed to make room for new stuff.
Okay, so to really push LM2 to the limit, researchers use the BABILong dataset. It's known for having really hard tasks that test an AI's memory and reasoning. And they also tested LM2 on something called the MMLU benchmark,
Mm.
which covers lots of subjects like STEM, humanities, everything.
And LM2 did really well, much better than other models on the BABILong dataset. It could even handle up to 128,000 tokens. That's a ton of text.
Wow, 128,000.
Yeah, and for context, a token represents a unit of text, like a word, or a part of a word.
Got it.
It also did great with different reasoning tasks, like single-step, multi-step, relation tracking. And it could even handle situations where there was negation or uncertainty. But what's really interesting is that LM2's better memory didn't make it worse at tasks that need general knowledge. It actually got better on the MMLU benchmark, which suggests that having a better memory might help it understand a wider range of things.
So to figure out what was happening inside that memory module, the researchers used something called neuron explainer. It let them see what was stored in the memory bank and how it changed during a task. They gave a really fascinating example using a question about photosynthesis.
So initially, the memory bank focused on words like France and Paris, which seemed completely unrelated to the question. But as the model learned more information, its focus shifted to words directly about photosynthesis, like plants, process, and photosynthesis itself.
So it sounds like the memory module is actually adapting as the AI is processing information, almost like it's learning in real time.
Exactly.
It's not just storing things, it's actually figuring things out as it goes.
It's like, it's almost like a student. You know how when you study, you start to focus on the really important parts of a topic? That's kind of what's happening here.
It's really interesting that it went from those random words to words about photosynthesis.
Right.
It seems like the memory module is more than just a storage unit. It's an active part of the process.
Right, yeah. And using this neuron explainer method, it really gave researchers a way to see how LM2 works. By analyzing what's in the memory bank, they could see how the model changes its focus.
That ability to see how the AI is thinking, that's so important.
Yeah, it gives us valuable insights into how AI solves problems.
It's something researchers have wanted to understand for a long time.
Neuron explainer is a tool to make that process more transparent.
And the researchers, they chose a pretty complex topic for this example, photosynthesis.
Yeah.
It's a really important process in biology, but it involves a lot of different steps and concepts.
And the fact that LM2 could handle this complex topic, even when it started with those seemingly random words, it shows how adaptable the model is.
Yeah, that initial focus on France and Paris is strange. But maybe the AI was trying to understand the structure of the question first. Or maybe it was looking for any geographical connections before going into the science part.
Yeah, that's
It's
possible.
like it was trying to build a foundation before focusing on the specific knowledge it needed.
It seems like the memory module doesn't work alone. It works with the model's ability to reason. That's what lets it adjust its focus.
Yeah, having both memory and reasoning is really important. It's how we're going to get closer to AI that can learn like humans.
And LM2 did well on both the BABILong and MMLU benchmarks, which means it can handle tasks that need a lot of memory and tasks that need general knowledge. It's a big step toward AI that can tackle more real-world problems.
You mentioned earlier that a token represents a unit of text. Can you explain a little more about how those tokens are used?
Sure, so tokens are like the building blocks of language for these large language models. They can be words, parts of words, or even punctuation. And AI models use tokens to analyze and understand language.
So when LM2 handled 128,000 tokens, in the BABILong dataset. It was dealing with way more information than most AI can handle.
Right, that's a huge amount of data. It shows that LM2 has a really impressive memory.
And that opens up so many possibilities. Think about things like legal research, where AI could help lawyers analyze tons of legal documents.
Yeah, that would save them so much time. They could focus on the parts of their job that really need a human touch.
And in scientific research, imagine AI helping scientists find important discoveries.
That would be amazing.
The possibilities are endless.
The main takeaway here is that LM2 is a big step forward. It can understand lots of text, and it can reason in sophisticated ways.
But it's important to remember that this is still early research.
Yeah, it's just one step on a long road to building truly intelligent AI.
A road full of challenges and opportunities.
And this neuron explainer method, it's like having a window into how an AI thinks.
It's going to lead to even more amazing discoveries. This LM2 large memory models paper, it really gives us a look into what AI could be capable of. And the fact that we can actually look inside these models now with neuron explainer, that's huge.
That's a big step.
The things we learn from this kind of analysis is going to help us build even better AI in the future.
Oh, definitely.
We've talked about legal research and science, but the applications for LM2 go way beyond that.
Think about AI that can help writers. It could draw on a huge amount of knowledge and understand how language works to help them create amazing stories.
Or AI tutors that can adapt to each student,
Yeah, that would be great.
giving them personalized lessons.
AI that can remember and reason like this, it could change so many things about our lives.
But of course, with this kind of power comes responsibility,
Right. We have to make sure we're developing AI ethically.
and that we use it responsibly.
Transparency and accountability are really important.
This research shows how fast AI is advancing.
It's incredible.
We have to stay informed and engaged.
If you want to learn more about LM2, the full research paper is definitely worth a read.
You can find a link to it in the show notes.
Keep learning, keep exploring. Let's keep pushing the boundaries of AI together.
Thanks for joining us on this deep dive. It's been a fascinating look into the world of large language models.